The church is embezzling money.
Okay. Lesson 58. Reviewing what it means to be explicit versus implicit equation or function, and then reviewing what it means to be an inverse function and how to find that. So, top of the page, we're talking about explicit and implicit. You use them both all the time. You probably just don't necessarily remember their names. An equation that is written y equals or f of x equals. So in other words, an equation that is solved for y is an explicit equation. Okay, it's in its explicit form when it is at that point of y equals. So in other words, when you get it in that form and you're ready to use the graphing calculator with it, you've got it to be y equals. You're in that explicit form. Or the other thing is, when you've got it y equals and it's really easy to plug an x value in because you just plug it in and do all the math and you get your answer. That's our explicit form. That's our form that we prefer to work with most of the time. An equation involving x and y, but not solved for y, so not an explicit form, is called implicit form. So implicit is just one of those messy equations. You've got x's and y's mixed in together. You know, not solved, not nice, neat, y equals. The equations can mean the same thing, yet look different. In other words, you can have an equation that could be explicit and implicit look totally different, but still be the same equation. A good example is logs and their exponential form. If you remember, y equals log base 10 of x. You can take something out of log form. We usually talk about left, right, middle here, which this one, it's flip-flop for left, right, middle, isn't it? But so you would go 10 raised to the y equals x, and that's your implicit form now. The y equals log base 10 of x is solved for y. It's y equals, there's your explicit, 10 to the y equals x is implicit. And this is sometimes why we go back and forth, especially with logs and exponents, between explicit and implicit, because what do you do with 10 to the y equals x? That's a little bit harder to work with. We've basically got the other ones, just the x and y are in opposite, or I guess log and exponent are in the opposite forms, but y equals 10 to the x. Okay, given the exponent equation, we can backtrack and put that in the log form. So log of base 10 of y equals that power of x. And again, this is kind of ugly when y is within that equation and it's not y equals. This is the nicer version to work with. Y equals 10 to the x. So just explicit versus implicit. Good to know the difference in those definitions. Okay, unless you guys have anything, let's talk about inverse. Inverse functions. We did inverse functions, I would say the last 2 years for most of you. Maddie, you've probably done them the last 2 years too, you know. But I know we did them in Algebra 2. We talked about them in Pre-Cal. So inverse functions, y, for instance, finding the inverse of y equals 2x plus 4. That's a pretty basic one. You guys remember anything about finding the inverse?
Change the variable.
Yeah. In order to find the inverse, we're going to take the x and the y and we're going to switch them, right? And so you'll notice right here, the implicit form of the inverse is x equals 2y plus 4. Okay, that is taking our x and our y and switching them, and that is the implicit form because it's not solved for y. However, when we find inverses, what are you usually expected to do then? We don't usually stop and say x equals 2y plus 4. We usually then solve. So if we have 2y plus 4 equals x, what's this going to be when you solve it for y? Okay, so we subtract the 4 over, it's 2y equals x minus 4. And if you divide by 2, I heard Ethan say x minus 4 divided by 2. We could also say if we divide each term by 2,
It'd be like x over 2 minus 2, right?
yeah, x over 2 minus 2, or my brain was saying 1/2 x minus 2. I agree, x over 2 minus 2 is equivalent. Ethan's x minus 4 over 2 is equivalent. Honestly, it all depends what you're doing with that equation, right? If you're just plugging in x values, I'd probably go with Ethan's, honestly. If I'm graphing it, I'm going to go with this slope-intercept form that Ross and I kind of talked about. So it depends what I'm doing with it. They're both good forms. Okay, so that's a little bit of review about inverse there. And when we get down, we're going to practice in this example 1 here. The other thing that we need to review, I believe it was new in pre-cal last year, talking about what it means to be one-to-one. I know we've done it already this year in pre-cal. Okay, so when we looked at the graph, if a function is one-to-one, it passed not only the vertical line test, but it also had to pass the horizontal line test. And that was our first introduction of the horizontal line test. And I think that must be chapter 1, maybe. Chapter 1 or 2, because I've already done it this year in pre-cal.
It's like that.
Yeah, it's got to be over a year ago in your brain. So, okay. So, one-to-one functions. If you have a graph to look at, it has to pass the vertical line test and horizontal line test, and that's how we know it's one-to-one. The other option, and we did this, we might have even done this actually in Algebra 2, but for it to be one-to-one, you have to look at the compositions. So the inverse composed with f has to equal x, and f composed with f inverse has to equal x. And I think we've done that the last 2 years, honestly. But just the idea that if it is one-to-one, or we might have talked in Algebra 2 to show if the inverse is a function, is what we were probably doing back then, those both had to equal x. And so we're going to practice that down in example 1 also. Oh, okay. Sorry, I have a random graph written right here in my notes, and I was trying to figure out why I have this random graph in my notes, but it has to do with this key comment right here. The graph of any function and the graph of its inverse are reflections of each other in the line y equals x. Does this sound familiar?
So,
Okay. For instance, if we think about the exponential function. The exponential function is the one that runs along the x-axis, right? Crosses the y-axis around 1. That's the exponential function, yes? What's the inverse of the exponential function? And that is the log function, right? And so what's the log function look like? It's the one that goes something like that. Well, if these are truly inverses, what you will notice about the graph is they reflect across the line y equals x. And the line y equals x is that perfect diagonal line that goes through 0, 0, 1, 1, 2, 2. And so that's an example of a function and its inverse being graphed, because you can see there. Okay? Okay, let's look at example 1 here. It says let f of x equal 2x minus 3, so they give us the basic equation. And they want us to find f inverse of 4. And so that's going to be the main thing. We're also going to prove here in a moment that the function and its inverse, we're going to check and see if it's one-to-one. But for right now, what do I have to do to find f inverse of 4? We have to find the inverse. What's my first step in finding the inverse? Switch the variables, which, what do you guys know f of x to be? That's y. So if you want to briefly think, it's y equals 2x minus 3 officially. But then to actually find the inverse, I'm going to switch x and y. And so instead of saying y equals, I'm going to write x equals. Instead of 2x minus 3, I'm going to say 2y minus 3. And now I'm going to,
Do we just plug it in now, or do we have to solve it first?
if you plug it in now, you're going to have to end up solving it though. Because when you're that 4 is going to go in place of x, and so you still end up having to solve it. So usually we go ahead and solve it now. Solve it and try and get it y equals, which means I'm going to add 3. So I just wrote x plus 3 equals 2y. I should have flipped that is what I should have done, but what do we get when we divide by y? Not divide by y. Divide by 2. Yeah, and this is where, I guess it depends what we're doing with this, right? You could say x plus 3 over 2, or you could say 1/2 x plus 3/2. They're both good. They're both equivalent. Again, it comes down to, like everything I say in AP, knowing your equivalent forms, right? So, looks like I actually did the 1/2 x plus 3/2, but I don't know that that's necessary. So, officially, if this is an inverse, I should always go back to that form and denote it as f inverse of x. Honestly, x plus 3 over 2 is probably going to be easier for everything we're doing today, to be honest. So if I want to find f inverse of 4, now I'm going to plug in 4. 4 plus 3 divided by 2 is going to be 7/2. Now, the other piece I want to do before we stop for today is I want to practice with this right here. The fact that I want to practice showing that a function is inverse or one-to-one using algebra. So not using the graph and the horizontal and vertical line test. So we're going to use it on these functions here. So we were given the function, what? F of x equals 2x minus 3. And what did f inverse of x end up being? X plus 3 over 2 is one of the forms. You could, again, you could use either form here. So, take them and compose them. So if I'm trying to do f composed with f inverse of x. Okay, so if you remember your compositions from your algebras or pre-calcs, that means I'm really doing f of f inverse of x. Which means I'm doing what?
You're taking all the x's in f of x and replacing them with x inverse, right?
Okay, yeah. F inverse goes into f. So every time I see an x in f, which is this 2x, right? I'm going to put f inverse in there. So if my f is 2x minus 3, it's going to be 2 times x plus 3 over 2 minus 3. So I replaced f inverse right in there. What do you know about 2 times x plus 3 over 2?
It's just x plus 3.
Yeah, the 2's are going to cancel. And I'll have x plus 3 minus 3. And what's x plus 3 minus 3? X. So that one checks out, right? That's half of the, valid answer that yes, this is 1-to-1, but it has to be true for both, which means that was F composed with F inverse. We also have to do F inverse composed with F. So I'm doing F inverse of F of X. So now I'm going to take F and put it into F inverse. So F inverse is X plus 3 divided by 2. Except what am I putting in for X plus, or the X? 2X minus 3. And let's see, 2x minus 3 plus 3 is 2x over 2. And 2x over 2 becomes x. Both cases, my compositions ended up being x, so that means that this is 1-to-1. If we graph these, they would be a reflection across the diagonal line y equals x. So as I said, review about what it means to be implicit explicit, using a little bit of implicit explicit, review of inverse. Not really a lot of calculus today, more just math stuff. Questions here? Okay then.